In this video, we will rebut Dan Olson's assessment of the 2014 movie, The Principle. Since we will leave no stone unturned in Mr. Olson's rather scurrilous review, the rebuttal will run over 2 hours. In the end, it is our confident hope that you will realize that almost every single fact and interpretation of said facts by Mr. Olson are false. We will allow Mr. Olson to state his case without deletion. When we think it is necessary, we will interrupt and give our commentary, and when we are finished with a particular section, we will continue with Mr. Olson's review. The video will continue in this format until the end.
Yeah, I remember when I first learned about the principle. Can you just introduce yourself real quick? My name is Dan Olson. I am the writer and director of In Search of a Flat Earth. I first became aware of the principle when I was working on a documentary about flat Earth philosophy. There was this particular flat Earth channel on YouTube, and I was going through all the most watched videos on the channel, taking notes, and one of them, this 2-hour video, had just these long clips from some other documentary about Copernicus and Kepler and Brahe, and it was actually kind of decent quality animation, and Kate Mulgrew was narrating, and it said on screen explicitly, used with permission, such and such films. And I thought, you know, that's odd.
The greatest astronomer of the time, Tycho Brahe, developed a new geocentric model. The Earth occupies the center, the planets orbit the sun, and the sun orbits the Earth.
You know, YouTube culture being what it is, it's already unusual for anyone to actually ask permission, let alone on Flat Earth YouTube. So right away, that told me that something was up. Clearly, the people who made this first video, which was just an anti-science screed on a channel full of flat Earth, anti-vax, ancient alien stuff. Clearly all of these people were on the same wavelength. And that's weird. There's not usually a lot of crossover between random YouTube cranks and the kind of people who are able to get in touch with Kate Mulgrew's agent. So I prod a bit, and it turns out there's a whole buck wild story behind that. It had actually made a small splash when the film first came out in, I think it was 2014. You know, this documentary about how Earth is the center of the universe and the sun orbits the Earth, and they tricked a bunch of astrophysicists into being in it, and
let us say, categorically, no one was tricked. Everyone was told it was a scientific documentary about cosmology, including alternative views of cosmology. Yes, geocentrism was not mentioned in the contract, just as heliocentrism, or acentrism, or the Big Bang, or the multiverse, or string theory, or the steady-state theory, or hologram theory, or any other theory were not mentioned. To say any more in the contract would be to compromise the film, since the film sought for honest and objective answers from the participants, not couched or biased answers formed from a prejudice against other views. Hence it had to be only in the actual interview that the participants would be challenged with alternative views to theirs, and thus they could answer based on questions they were asked of other views of cosmology. This is why each participant, at some point in the interview, would be presented with a geocentric alternative so that they could form their opinions based on the scientific facts brought to them during the interview and not on knee-jerk reactions from prejudice. As such, the participants were also presented with the views of the Big Bang, the multiverse, string theory, steady-state theory, quantum theory, and even hologram theory. Each of the participants then gave their opinion on each theory without having previous knowledge of the way other participants had answered the questions about each theory. For example, George Ellis did not believe the multiverse theory was correct, whereas Max Tegmark and Bernard Carr thought it was correct. Ron Hatch disagreed with all the Einstein-holding participants, while Julian Barber was against all those not admitting to Markian mechanics. Michio Kaku was the only one to admit to the problem of universal expansion, while others did not even mention the problem. Whatever the answers, the goal of the movie was to give each cosmological view a place at the table to tell their story, which is what any fair documentary should do. Geocentrism is just one out of many views of the universe, and it has been around a long time. Although some time later various critics didn't like that the producers of the principle were giving geocentrism a voice, the irony is that it was because of at least two of the six mainstream physicists in the principle, namely, Julian Barbour and Lawrence Krauss, who are two of the more respected physicists in the world, that started us out in our research in 2004 that finally became the movie, The Principle, 10 years later. Barbour had been pointing out the flaws in Newtonian physics for many years as well as praising its replacement, Machian physics, which then led to Einstein. It came to a point in which Barbour said this resigning statement in his book, Absolute or Relative Motion, published by Cambridge University Press in 1989, page 226, quote, "Thus, even now, 3.5 centuries after Galileo's condemnation by the Inquisition, it is still remarkably difficult to say categorically whether the Earth moves, and, if so, in what particular sense." Unquote. As for Dr. Krauss, he went even further. In 2006, he made an astounding statement in the magazine titled, The Edge, defending the possibility of a geocentric universe, which we will address in detail later. What was most surprising to us was, the more research we did, the more scientists we found who were saying the same thing as Krauss and Barbour, most of which we could not fit into the movie due to 90-minute time constraint for the typical theatrical movie, as well as the task of getting them to remark on their geocentric findings on a Hollywood camera, as opposed to scientific journals where scientists only communicate with scientists. Despite the evidence that Dr. Krauss and the others admitting to the plausibility for a geocentric universe, the mainstream media refused to give it any credence, no matter how convincing the evidence was from the scientific experts. In the end, the media's bias actually helped prove the principle's point by showing the Copernican Principle rules virtually all of modern science, and thus they insist that a non-Copernican theory have no place at the intellectual discussion table. But it was our goal, obviously, to give everyone a place at the table, and let the audience make its own decision. That endeavor cost our company, Stellar Motion Pictures, about $2 million. We knew going in that if you want to play in this high-stakes game, you needed something close to high-stakes money. Our research into the admissions of a geocentric universe from some of the world's most popular physicists took almost 10 years. We had to dig deep into the scientific journals and peer-reviewed papers to see and understand how Krauss and others arrived at the possibility of a geocentric universe. But once one reaches this rather hidden level of scientific expertise, there is not only a plethora of literature about the possibility of a geocentric universe but the equal possibility of the demise of the Copernican universe or Copernican Principle, but you are not going to hear about it on the CBS Evening News and certainly not from someone like Dan Olson. Although some of the mainstream physicists in the Principle made no movement toward a geocentric universe, they all remarked on the weakness of their own view, the Copernican Principle. One of the main reasons for this shift in thinking is that we have new information about the universe that mankind has never seen before, much of it coming from about a half-dozen space probes sent up in the late 1970s through the 2000s that show the geocentric universe that even Dr. Krauss was amazed to see and then mentioned in the Edge magazine in 2006. Since this is so, obviously geocentrism deserves a place at the discussion table. Anyone who can't see that fact is not dealing with reality. They are denying its plausibility because of personal prejudice, as well as a deep disdain for its purveyors because, as Mr. Olson will eventually refer to them later in his video, they are nothing but, quote, religious zealots, unquote. Case in point. Contrary to what Mr. Olson will claim, geocentrism has never been discredited, as we shall see when Mr. Olson attempts to present three of his own scientific proofs against geocentrism, namely, stellar parallax, Lagrange points and black holes. Each of his proofs fail. In the end, they only show how ignorant Mr. Olson is of the science. In fact, as we shall see, the greatest scientists to admit to a geocentric universe was Albert Einstein, a fact of history that is kept under wraps in the halls of academia. At first Einstein tried to avoid a geocentric answer in his special theory of relativity, but 10 years later in his general theory, he had no other choice but to accept geocentrism as a viable answer to the scientific evidence. And there were many other scientists during his time that said the same thing, and we shall see their statements to that effect. As we shall see, even Isaac Newton, deemed as the master scientist who produced an irrefutable dynamic heliocentric model, still gave room in his day for a geocentric universe if certain conditions were met, a piece of evidence that has only come to the surface when certain back pages of his Principia Mathematica were recently found. As noted, the most interesting thing we discovered in the course of making the movie is that many of the mainstream heliocentric and Big Bang participants were willing to admit there now existed a significant amount of scientific evidence that either did not support the Copernican Principle or didn't bode well for it, and thus the movie accomplished its goal. In further rebuttal to Mr. Olson's accusation that we, quote, tricked people into being in the movie, unquote, let us next deal with the case of Kate Mulgrew, who was the narrator for the movie. Briefly, we chose Miss Mulgrew as the narrator because of her unique baritone voice, and also because she played Captain Janeway on Star Trek Voyager in the mid-1990s, which gave her an aura concerning things scientific. She was selected over a number of other entertainment stars such as Della Reese, David Bowie, Sigourney Weaver, and Gordon Sumner. After our company, Stellar Motion Pictures, contacted her agent in New York and made a contract with them for $25,000, Ms. Mulgrew read the script and approved it and then signed the contract on May 6, 2013, which scheduled her narration of the script for June 6, 2013, which she gladly fulfilled. Since she approved the script, there was obviously nothing in the script about which she objected when she read it in private, otherwise she would have told us before signing the contract. Then a few weeks later, we sent our crew to New York to do the actual interview. In all, Miss Mulgrew took only 2 takes to make the narration perfect. After she was done the narration, she was so impressed with its contents that she asked to have a separate interview with the director so that she could express her enthusiasm for the movie. This was a complete surprise to us because the contract did not guarantee she would agree to an interview. In other words, Kate Mulgrew went beyond her own contract because she wanted to tell everyone in the world, on film, how good the movie was, and we still retain it today on the Principle website. So, Ms. Mulgrew did a 10-minute interview to express herself. At one point in the interview she told us that to do a good job in the narration, she had to thoroughly study the material to make sure she knew what it was saying. She said she needed such conviction because it led her to put deep emotion into her reading of the script. Here is part of the interview.
Well, it's thrilling. One could say that I had 7 years of preparation for it and playing Captain Janeway, who was a scientist and an ardent one at that. It's great. First of all, the material to me is fascinating. Secondly, I'm not on camera. So there's something very private, relaxed, and deeply creative about it, especially when I find that the language is as advanced as this is. It's a pleasure. We discussed, on breaks, a lot of what this science could mean, and all of that is titillating, fascinating, intriguing to me, because the what-ifs of the world are what makes the world so fascinating. Well, I think you probably gave me that license by saying, just do what you want to do. When you say that to an actor, then they usually invest 100%. And you're quite right and very astute to see that the first time around, a lot of this stuff is difficult. I have to organize it in my mind. I have to fully understand it. I have to separate it out. It has to make perfect sense to me so that the second time around I can endow it with all the emotion it deserves. And that's what I did. The second time around is just like the luge. The first time around is, running the track. In this situation of a voiceover, I'm much freer. It's contained. It feels insular. I feel safe. There's not a moment's safety on a stage. You're on the ice. So that's the difference. That's why this is just always such great fun for me. I thank you for the opportunity.
In April 2014, we released the trailer for The Principle. 2 weeks later, one of our ideological foes, a renegade in Catholic circles named Mark Shea, who deeply desired to destroy any prospects the movie might have, contacted Lawrence Krauss by email and told him that he was secretly cast in a film exclusively promoting geocentrism. Krauss said he didn't know anything about such a film and that the makers probably just took clips of him off YouTube. Krauss' denial is understandable, since the producers of The Principle, Robert Sungenis and Rick Delano, never promoted the film as one exclusively about geocentrism, but about the new discoveries in cosmology that were bringing into question the Copernican Principle, the current position of modern science that treats Earth as a speck of dust in a vast universe that has no rhyme or reason to its existence, a position that, if false, opens up, by default, the ancient concept of a central Earth, and its natural significance. Somehow the media got a hold of Krauss' denial and it took on a life of its own. Within a week or two, over 150 news outlets across the world were slamming The Principle as a farce, made by two amateurs who were heavy into traditional Catholicism. By the fourth week of April 2014, bashing of The Principle was the third highest trending story on the internet. Someone or some group with some very powerful tentacles was intent on destroying The Principle before it ever gave birth. The most amazing thing about the worldwide media attack is that it came 6 months before the movie debuted in US theaters in October 2014. In other words, none of the world's hundreds of critics had seen the movie, and thus The Principle became the most critically reviewed movie in Hollywood history by critics who had never seen the movie. We certainly had put a new category on the list of how to evaluate feature films, and we certainly exposed a very hot third rail that no one was permitted to touch. The only thing on which the critics had to base their negative reviews was the trailer of The Principle, a trailer which, incidentally, never mentioned the word geocentrism, but did emphasize the possible demise of the Copernican Principle. But in viewing only the trailer, the critics, who were all believers in the Copernican Principle, were convinced that their worldview was under attack and thus they did their best to destroy any hopes that the 90-minute feature film would make it to the theaters. In addition to accusing Robert Sungenis of being an anti-Semite, which is not true, they accused the producer of molding the participants' views to agree with geocentrism, which was not true, as well as saying that there was no science to support anything but a Copernican worldview, which is not true, and summed up the Principle's efforts as nothing but a religious stunt, which was not true, and these were some of the more mild accusations they levied against the movie. From another perspective, as they say in Hollywood, any publicity is good publicity, since the media reviews made The Principle one of the most talked about science documentaries on record. In that sense, we accomplished what we set out to do, since no one in recent history had been able to put a question mark on one of the most revered ideological views the world has ever held, the Copernican Principle. When the press needed fodder to keep the pressure on The Principle and the studio that produced it, Stellar Motion Pictures, LLC, they immediately came knocking on Kate Mulgrew's door in April 2014, telling her all the juicy gossip they had found. Poor Miss Mulgrew had two choices. A. To disavow The Principle and imply that her voluntary and enthusiastic interview for the movie was given under false pretenses. Or, B. Be accused of siding with scientific quacks and thus ruin her career. Even though Miss Mulgrew is a Catholic herself, it would certainly be difficult for her to siding with alleged quacks, especially since she had a TV series running at the same time titled, Orange is the New Black. Since the producers of The Principle were already controversial, all those against our new research into cosmology took the opportunity to crucify us with the hope that we would never rise again. The sad irony is, had they seen the movie before they made their biased judgments, they would have seen that it was the participants themselves, such as Michio Kaku, Max Tegmark, George Ellis and Lawrence Krauss, who were spilling out long-winded accounts about the shaky foundation of the Copernican Principle based on a whole new set of scientific data the world had never seen before. If it was the case that geocentrism had answers for these problems, which some of the mainstream scientists in the movie had already admitted decades prior, it is news the public should know, and we were determined to make it known, come hell or high water. But in this age of political correctness, neither the media nor the strong financial and ideological arms behind them were worried about smearing the principle or ruining our reputations with ad hominem attacks. They had a vested interest in doing so. As we see it now, almost 10 years later, it was all we could expect from the world at the time, because we had put them all into a state of shock, that something as vaunted as the Copernican Principle that had directed human affairs for the last 500 years, could be totally wrong. Only time will tell what the final effect will be.
I want to talk about, but then, as I was digging a bit deeper, I realized that the executive producer, Robert Sungenis, a man with a doctorate degree from a fake university.
Let us say first that Robert Sungenis has 2 US accredited degrees, a bachelor's from George Washington University, in which 2 years of his time there consisted of courses in the sciences of physics and chemistry. He also has an accredited master's degree from Westminster Theological Seminary. Mr. Olson can correct us if we are wrong, but that is 2 accredited degrees more than he possesses, as even he will admit later in his video.
Mercury. Straight. Venus? Come on, bye. Obvi. Mars? Also bi, but almost exclusively dates men.
Prior to producing the principle, Robert Sungenis was 2 years into an accredited PhD program in England, at the Maryvale Institute, which could not be completed because of logistical and family constraints, since Robert is the father of 11 children and the director of 2 businesses. Mr. Olson's charge that Robert's PhD comes from, quote, a fake university, unquote, is quite false, not to mention slanderous. A fake university is one that is not real, or one that advertises false information, or that pretends to be something that it is not, some of which are known as diploma mills, that give out degrees for money, without requiring any academic work from the recipient. Calamus International University is none of those. It is a legitimate university authorized by the country of Vanuatu. The only difference between Calamus and other popular universities is that Calamus is not accredited in the United States or by any other accrediting party, but Calamus has never sought for such accreditation for its own ideological reasons. The country of Vanuatu allows academic institutions without third-party accreditation, as long as they are domiciled in Vanuatu, to issue PhD degrees under the authority of the government of Vanuatu. The country of Denmark does the same. Still, to enter the Calamus PhD program, the student is required to have a bachelor's and master's degree from accredited institutions, and have these degrees in the same subject matter that the student will pursue at Calamus. Since Robert already had 2 degrees in religion from US accredited institutions, he was accepted by the Calamus PhD program, in the same field of study. Calamus models itself from what is practiced in many accredited European universities, that is, they permit PhD research degrees that do not require classroom sessions, thus allowing the student to fulfill the PhD requirements off campus. In turn, the PhD student is required to write a formal PhD dissertation within a 3-year period, a dissertation that must be written under the supervision of another PhD, which requirement was fulfilled for Robert by Dr. Robert Bennett, who has PhD in physics from the accredited Stevens Technical Institute, in the United States. When Robert's dissertation was completed 2.5 years later, it was 700 pages long, and was judged by the Calamus Board of Directors as excellent in 9 out of 9 categories and one of the best dissertations ever received by the university. The PhD was issued in April 2006, after which the dissertation was immediately made into a published book.
Effectively interviewed himself in his own movie in order to make himself look like an expert. and and it was just like, that's it. I have to talk about this now.
So, in Mr. Olson's vast experience in making movies, which consists of exactly one film on YouTube titled In Search of a Flat Earth, where he, interestingly enough, interviews himself on camera as an expert in Earth science and physics for 1 hour and 16 minutes to show how the flat earthers have gone wrong, now wants to marginalize Robert Sungenis for being filmed in the movie Robert created and produced. Perhaps Mr. Olson can someday explain how that bit of skewed logic and blatant hypocrisy amounts to a convincing argument. In fact, if Mr. Olson's criticism were valid, that is, that a producer or director shouldn't be interviewed in their own movie as an expert, that means that all the Hollywood producers and directors over the years that were interviewed in their own documentary films were disgracing themselves, including people like Michael Moore, who made Fahrenheit 9/11, and Bowling for Columbine, and recently Michael Moore in Trumpland, and was just an egotistical maniac looking for attention but pretending to be an expert. In fact, the list of producers or directors who appeared in their own films and were interviewed is rather amazing. Wikipedia gives many examples, including Clint Eastwood, Spike Lee, Quentin Tarantino, Orson Welles, and dozens more. This is especially true in documentaries in which the producer or director have a vested interest in disseminating the vital information the documentary is trying to teach the public. And, true to form, in his present venture into amateur film making, in which Olson seeks to neutralize the principle, he makes no mention of the fact that Robert Sungenis is on Olson's side in the flat Earth debate, since Robert wrote a 740-page book 3 years ago, titled Flat Earth, Flat Wrong, which debunks the flat Earth hypothesis from a biblical, historical, and scientific perspective. He also makes no mention of the over 50 books that Robert has published over the last 30 years, from 4 different publishers, half of them dealing with science issues. Of course, if Olson had mentioned Robert's book against the flat Earth hypothesis, it would have given Robert some well-deserved credibility, but credibility was the last thing Olson wanted to lend to Robert Sungenis. Just for the record, the director of The Principle, Catherine Thomas, asked Robert to be interviewed just like she asked every other participant. Robert then signed a contract with Stellar Motion Pictures just as every other participant did, although he chose not to receive any monetary compensation. Robert was chosen to be interviewed by the director and producer because they knew, from all the books, lectures, and debates Robert had produced over the previous 2 decades prior to the movie, none of which Olson indicates he has read in order to understand why Robert holds the views that he does, that he was, indeed, an expert in both the theological and scientific sides of the matter and would thus be good to teach both sides to the audience. Despite all this history, however, Robert appears for only 6 minutes in his 90-minute film, hardly what anyone would call stealing the show. Conversely, Dan Olson interviews himself for over an hour in his 1 hour and 16-minute film. Lastly, we can only say that, after watching Mr. Olson's personal antics in this current video, as well as seeing his almost total lack of knowledge in both the science and theology, he has no concept of what it takes to be an expert in a film of this nature, the evidence of which we will provide in the upcoming parts of this video. For the time being, all Dan Olson knows is that, being either an agnostic or an outright atheist, he doesn't like the Christian message he sees seeping out of The Principle or in the other material Robert Sungenis has produced over the years, and he's going to do his best to convince his audience to reject them both, along with a good measure of sarcasm, slander, and innuendo.
Okay, first things first. The Earth is not the center of the universe. I'm putting this at the front because I don't want to have to debunk every random-ass claim the filmmakers toss out as they come up. The folks who made this film are going to make a number of claims that are just wrong. We have, in fact, demonstrated that the Earth orbits the Sun. Stellar parallax was first measured in the 1830s and has only gotten more precise since.
If Mr. Olson had studied parallax before he made his video, then he would have found out, as many modern scientists have discovered since the dawn of relativity in the 20th century, that stellar parallax cannot, and does not, prove the Earth is not in the center of the universe. Why? Because the geocentric model shows stellar parallax just as does the heliocentric model. The only difference is what one puts in the center. Let's start first with the heliocentric version. As one can see, parallax is caused because the Earth, as it moves from one side of its orbit to the other side in 6 months, will view the same two stars from a different angle. This will make it appear that the closer star is moving right to left or left to right against the farther star. Now let's do the geocentric version. As one can see, parallax is caused because the whole star field, led by the Sun, is revolving around the Earth, going from one side of the Earth to the other in a 6-month period, on a radius of 93 million miles. This makes it appear that the closer star to Earth is moving right to left or left to right against the farther star. If Mr. Olson denies this possibility, then he either doesn't know the science as he claims, or he does know it and is deliberately hiding it from you. But don't take just our word for it. Here is a quote from a physics professor from the University of Illinois.
It is often said that Tycho's model implies the absence of parallax, and that Copernicus requires parallax. However, it would not be a major conceptual change to have the stars orbit the Sun, like the planets, for Tycho, which would give the same yearly shifts in their apparent positions as parallax gives. The presence or absence of parallax doesn't force the choice of one type of model over the other. If different stars were to show different amounts of parallax, that would rule out the possibility of them all being on one sphere, but still not really decide between Tycho and Copernicus. In fact, if we don't worry about the distant stars, these two models describe identical relative motions of all the objects in the solar system. So the role of observation is not as direct as you might have guessed. There is no bare observation that can distinguish whether Tycho, taken broadly, or Copernicus, taken broadly, is right. Taken from the University of Illinois, Physics 319, Spring 2004, Lecture 3, page 8.
Parallax was first measured in the 1830s and has only gotten more precise since, and Lagrange point satellites behave the way that they do because we accurately understand how gravity behaves on celestial objects, an understanding that has enabled us.
The Lagrange points prove nothing for Mr. Olson. In actuality, it shows his ignorance of the geocentric system. Whether one is in the geocentric or heliocentric model, both are going to have the same Lagrange points around the Earth, because both models understand that the gravitational field between the Sun, Moon, and Earth intermingles to form various neutral points, regardless whether the Sun is in the center or the Earth is in the center. Lagrange points won't change if the Earth takes the Sun's position and the Sun takes the Earth's position. These 5 neutral gravitational fields will show up around the Earth in any case. But you've probably never heard of Lagrange points. Even if you look it up on Wikipedia, the Wikipedia authors are of the same Copernican mentality as Mr. Olson, and therefore you are only going to find the heliocentric version. Like Mr. Olson, they are all working off the discredited idea that geocentrism has been disproven. Since the neo-Tychonic geocentric model and Copernican Keplerian heliocentric model are just mirror images of each other that only change what object occupies the center, they are obviously going to have the same Lagrange points. The more important question here is, in the geocentric system, what keeps the Sun at a distance of 93 million miles from the Earth, and allows the Earth to remain in the center of the universe? The explanation is quite simple to understand. It not only shows how the geocentric system works, it shows the flaws in the Newtonian system that, without borrowing from the geocentric system, could never explain how the solar system works or how to send a space probe to one of the planets. Let's first look at Newtonian physics. In this system, the Sun is at the approximate center as it assumes the largest portion of the solar system's center of mass. The Earth and the other planets are pulled in by the Sun's gravity, and in order to escape falling into the Sun, each planet must have a speed that keeps it away from the Sun so that the resulting path of the planet is a circle or ellipse around the Sun. The planet is said to produce its speed around the Sun by its inherent inertia or momentum, that is, a long time ago something pushed the planet, and once it is pushed it is said to remain in motion unless stopped by a greater force. Is there any problem with this model? Yes, there are at least two. First, it assumes, without proof, that the universe is absolute, that is, it is infinite and does not move. Since it believes the universe is absolute, then moving objects within it can travel in a straight line unless acted upon by a net external force, which is Newton's first law of motion. If the universe were not absolute and itself moved, then any object moving in the moving universe could not be said to be traveling in a straight line. It would travel in a curved or geodesic line, as is held by general relativity. Newton believed the universe was infinite because, since its objects all have gravity, then gravity would eventually wrap all the objects into a giant ball. Newton thought that if the universe were infinite, then this problem will not occur. But assuming the universe is absolute and infinite is really not allowed in empirical physics. In fact, Einstein considered these assumptions from Newton as the major defect of his system, and the very reason Newton's physics needed to be superseded by relativity. Here are Einstein's words. Quote, "One need not view the existence of centrifugal forces as originating from the motion of K', the Earth. One could just as well account for them as resulting from the average rotational effect of distant detectable masses, the stars and galaxies, as evidenced in the vicinity of K', the Earth, whereby K', the Earth, is treated as being at rest. If Newtonian mechanics disallows such a view, then this could very well be the foundation for the defects of that theory." Unquote. Taken from Hans Thiering's paper, On the Effect of Rotating Distant Masses in Einstein's Theory of Gravitation, 1918. Bertrand Russell said much the same. Quote, "Whether the Earth rotates once a day from west to east, as Copernicus taught, or the heavens revolve once a day from east to west, as his predecessors believed, the observable phenomena will be exactly the same. This shows a defect in Newtonian dynamics, since an empirical science ought not to contain a metaphysical assumption, which can never be proved or disproved by observation. And no observations can distinguish the rotation of the Earth from the revolutions of the heavens." Unquote. Taken from Dennis Sciama's The Unity of the Universe, pages 102 and 103. Here's another problem with Newtonian physics. Newton's most famous equation, F equals ma, that is, force equals mass times acceleration, is flawed. Why? Because whenever NASA sends up satellites or space probes they cannot use only F equals ma. They must add the three inertial forces to F equals ma so that the actual equation is F equals ma plus centrifugal plus Coriolis plus Euler forces. In fact, scientists must use this equation whenever they change from a fixed frame to an accelerated frame, or vice versa. But Newton's F equals ma obviously does not contain the inertial forces, so the engineers must add them in by hand in order to get the probe where they want it to go. But since the inertial forces are not an inherent part of Newton's system, they must refer to them as fictitious forces, because the engineers know they were added in artificially. One can find this information on Wikipedia. Quote, "As a result of this analysis, an important point appears: all the fictitious accelerations must be included to obtain the correct trajectory." Unquote. Wikipedia's reference to, quote, "correct trajectory," unquote, refers to the path that the space probe must take to get to its designated destination. Wikipedia's reference to, quote, "fictitious accelerations," unquote, are the three inertial forces, the centrifugal, the Coriolis, and the Euler. In other words, Newtonian mechanics does not work unless the three inertial forces, which are not part of Newton's system, are added to Newton's system. Interestingly enough, this quote was removed from Wikipedia in the past year and replaced by wording that was a little less stinging, which often happens when geocentrists quote from Wikipedia to support geocentrism. The remaining quote at Wikipedia says the following. Quote, "These additional forces are termed inertial forces, fictitious forces or pseudo-forces. By accounting for the rotation by addition of these fictitious forces, Newton's laws of motion can be applied to a rotating system as though it was an inertial system. They are correction factors which are not required in a non-rotating system." Unquote. Although this quote says essentially the same thing as the previous, one will not know this fact unless he knows the physics. Even without stating that the space probe will not have the proper trajectory, this quote still admits that Newton's laws don't work for most of the universe unless, quote, "correction factors," unquote, are added to his force equations. In colloquial terms, this means that Newtonian mechanics must add fudge factors to make it appear as if can calculate how to send a space probe to the planets. This sleight of hand has been used in Newtonian physics for over 300 years. Interestingly enough, the equation that runs geocentrism already has the inertial forces included. The reason is, a rotating universe's angular momentum produces the three inertial forces, and they are not fictitious, they are real. These inertial forces permeate the universe and work so that all the objects in the universe, from quasars to galaxies to stars, are kept in their respective positions and thus rotate with the universe around the Earth each day, the Earth being the universe's center of mass and is thus immovable. Technically speaking, whereas the centrifugal force pulls the celestial objects outwardly, the Coriolis force, which has twice the magnitude as the centrifugal, pulls the celestial bodies inwardly on a curved path, so that there is a net centripetal force that keeps them in their respective places in outer space. The Euler force is not applicable here since it only comes into play at the beginning of motion. But don't take our word for it. The source of our knowledge comes from the greatest scientist the world has ever esteemed, Albert Einstein. Although Einstein tried to avoid a geocentric universe in his 1905 invention of special relativity, when he came to his general relativity in 1915, he had no choice but to accept a geocentric universe as a viable scientific option. Not only did he accept geocentrism, he also said that in his general relativity the speed of light was not constant, and that ether had to exist, the very two things he had rejected in his special relativity. Einstein writes, quote, "We may say that according to the general theory of relativity space is endowed with physical qualities, in this sense, therefore, there exists an ether. According to the general theory of relativity space without ether is unthinkable, for in such space there not only would be no propagation of light, but also no possibility of existence for standards of space and time, measuring rods and clocks, nor therefore any space-time intervals in the physical sense." Unquote. Taken from Einstein's speech, Ether and the Theory of Relativity, an address he delivered on May 5, 1920, at the University of Leiden. As for the speed of light, Einstein said, quote, "In the second place our result shows that, according to the general theory of relativity, the law of the constancy of the velocity of light in vacuo, which constitutes one of the two fundamental assumptions in the special theory of relativity, and to which we have already frequently referred, cannot claim any unlimited validity." Unquote. Taken from Albert Einstein's Relativity, the Special and General Theory, 1920, page 76. The reason for these innovations from Einstein was that general relativity dealt with systems that were non-inertial, that is, they accelerated. Special relativity dealt only with systems that were inertial, that is, non-moving or not accelerating. As you probably know, there are few, if any, places in the universe that are non-moving or not accelerating, and thus general relativity basically rules the universe. We can see this in how scientists view the world today. They believe in the Big Bang theory and that the universe is presently accelerating in its outward expansion. But the Big Bang wouldn't work unless general relativity came to the rescue, because otherwise the Big Bang would have exploded too slowly to get the universe we have today, that is, if it were under the constraints of special relativity that only allows it to expand less than 186,000 miles per second, otherwise known as the horizon problem. So, back in 1980, a scientist named Alan Guth invented a concept called inflation, in which the Big Bang would explode by 10 to the 35 meters in 10 to the minus 35 seconds, a tremendous growth that is allowed by the equations of Einstein's general relativity. By the same token, these same Big Bang scientists now believe the universe is expanding at an accelerated rate, but if they used special relativity, the accelerated expansion could never happen since special relativity doesn't allow acceleration. So they use general relativity and now claim that the universe is expanding at least 4 times faster than the speed of light. But this only introduces another problem. Where does the energy come from to allow the universe to expand by at least 4 times the speed of light? First, there is no gravity source outside the universe that could pull the universe outward. Second, there isn't enough energy in the whole universe to push out the universe, since our universe contains less than 5% of the energy needed. Third, if they use quantum ether that they now believe in, it would give 10 to the 120th power too much energy. So, they must find another source. The problem is, there isn't another source. So in this case, they invent the energy they need and give it a name, dark energy, and proceed to look for it under every rock in the universe they can, but to no avail. Be that as it may, general relativity allows for another acceleration, an acceleration of the universe rotating around a fixed Earth, as in the geocentric system. Just like the accelerating Big Bang universe, light and material objects can go faster than 186,000 miles per second in the geocentric system, and therefore those stars and galaxies can whiz around the Earth each day just as they whiz outwardly in the Big Bang theory and obey all the laws of our best science. It's just a matter of where one is going to put the acceleration. One might ask that if the universe is accelerating in its rotation around a fixed Earth, where is it getting the energy it needs to keep up the acceleration? Well, that question is answered by the fact that a rotating universe has angular momentum. Once it starts turning, it will continue to turn, ad infinitum. And since the universe is so massive, and because there is nothing outside of it that could slow it down, it will go the same speed day after day without significant deviation, and that is why our sidereal day never changes from 23 hours, 56 minutes and 4.09 seconds. Conversely, a rotating Earth in such a vast and formidable universe that presents many external and internal forces against a small body like the Earth would soon overwhelm it and slow down its rotation, as has happened to other planets in our solar system. In reality, the geocentric system is the most stable system, while the Copernican system is unstable and fraught with many contradictions and inconsistencies. By the way, if you want to verify any of the facts that Robert has brought forth here, you can read about them in his books, available at www.robertsungenis.org. If Mr. Olson wants to try to disprove any of it, we will gladly engage him in a formal, open, and public debate. In fact, we issue the challenge here and now.
The way that they do because we accurately understand how gravity behaves on celestial objects, an understanding that has enabled us to, for example, detect black holes, as in this 23-year time-lapse of S2 orbiting the black hole Sagittarius A.
Sounds impressive, doesn't it? Mr. Olson knows about a black hole from a 23-year time-lapse of S2 orbiting the black hole Sagittarius A. But how does this picture of a black hole prove heliocentrism, and disprove geocentrism? If you notice, he doesn't tell us. You are just supposed to believe there is something inherent about black holes that disproves geocentrism. If his argument is that Lagrange points help us find black holes, well, he hasn't shown that geocentrism is devoid of Lagrange points, and thus he has produced a red herring to make it appear that he has disproven geocentrism. Now, keep in mind that, in these three examples, that is, Mr. Olson's presentation of stellar parallax, Lagrange points, and black holes, he has given us what he believes is his best evidence for proving the Earth is not the center of the universe. As he said it himself.
Okay, first things first. The Earth is not the center of the universe. I'm putting this at the front because I don't want to have to debunk every random-ass claim the filmmakers toss out as they come up.
So we would expect that if Mr. Olson had the proofs, he would provide us the most convincing arguments up front so that the audience could be amazed over them. The fact is, however, he's already given us two bogus claims of proof, one concerning parallax and the other concerning Lagrange points. Olson's third example is just an extension of his second example, since he is trying to say that since we see gravity at work as objects circle black holes in deep space, the implication is that geocentric cosmology doesn't have or believe in gravity. Perhaps Mr. Olson has been dealing with flat Earth advocates much too long, since he doesn't seem capable of distinguishing the flat earthers' refusal to use conventional gravity as opposed to modern geocentrism, which advocates and depends on conventional gravity, especially since Robert Sungenis supports it in his book Flat Earth, Flat Wrong, and has proposed an actual mechanism for gravity based on black holes in the Planck dimensions, in his book, A Googleplex of Tiny Black Holes. Mr. Olson would have known these things had he did a little research into Robert's books before he levied his scathing critique. So let's see what else Mr. Olson misrepresents as we move on in his video.
The central claim of the film is that the cosmic microwave background radiation indicates that the Earth is the center of a universal axis, which is just not actually true. They massage the data to make it look more significant than it really is, giving the misleading impression that it's a very precise axis that passes right through the Earth, but in reality it's a lot more vague than that.
Since immediately after this statement Mr. Olson goes on to his next topic, it becomes rather obvious that he is not going to give any scientific evidence to back up his claim that the cosmic radiation is, quote, more vague than that, unquote. Since Mr. Olson is not a scientist, he would at least be expected to cite a number of scientists who back up his claim. He doesn't mention even one. Why? Because there are none. Every scientist we contacted for the principle said that the cosmic radiation defies all previous cosmological studies that believed the universe was completely isotropic and Copernican. But don't take our word for it. Let's see what the scientists themselves said about this phenomenon. One of the first was physicist Joe Margejo. Along with his partner, Kate Land, they were the first to call the alignment of the Earth with the cold blue spots and hot red spots the axis of evil. Why did they call it evil, you ask? Because this unique alignment goes directly against modern science's belief in the Copernican system, as well as the Big Bang and the theory of evolution, in which everything is said to have occurred randomly and have no design. If there is a special line, a preferred direction, in space, especially with Earth at the center of it, then the universe is anything but random. And if Earth is in the center, it means someone much bigger and better than we had to put it there purposely, in that unique spot, since it could not happen by mere chance. It means the universe was designed around the Earth, to make the Earth have the preeminent position, just as Genesis says. One of the most astounding things Dr. Margejo said of the cold blue spots and red hot spots is this, quote, "It could be telling us something fundamental about our universe, maybe even that the simplest Big Bang model is wrong. The big question is, what could have caused it? Another way to create a preferred direction would be to have a rotating universe, because this singles out the axis of rotation as different from all other directions," unquote. Taken from the magazine, New Scientist, July, 2005, page 29. Did you catch that last sentence? To put it more simply, Dr. Margejo is saying that the special alignment of the hot red spots and cold blue spots of the cosmic radiation with the Earth in the center could be from a universe that rotates around a fixed Earth. This is about as close as we are going to come to having a modern scientist admit the Genesis account is how the universe was truly built, geocentrically. Two other scientists have confirmed this connection. Dr. Michael Longo of the University of Michigan, who is in the pre-cuts of our movie, The Principle, came to the same conclusion as Dr. Margejo. In his interview he said, quote, "If the universe was born with a spin, was rotating and had angular momentum, a spinning motion of charged particles like gas in the universe, always gives rise to magnetic fields. And that would cause some effects on the cosmic microwave background," unquote. The science magazine, New Scientist, had another article on the same phenomenon, and it stated, quote, "For example, if more galaxies are spinning one way than the other, this implies that the universe has a net spin, or angular momentum, in a particular direction. Since angular momentum can neither be created or destroyed, the universe must have come into existence in a spin. What set it spinning, though, and what is it spinning relative to?" Unquote. Taken from the article, Galactic Axis of Asymmetry Threatens Cosmic Order, New Scientist, August 22, 2012, page 2. Well, of course we know the answer to those questions, don't we? It's contained in the book of Genesis. The universe was born with a spin, and it continues spinning today, otherwise the effects would disappear. Only someone can start it spinning, and that someone must be God, since angular momentum cannot start itself. But let's add some more flesh to the skeleton Dr. Margejo has given us. Did you notice he mentioned the universe's axis of rotation? Well, it is not coincidental, since there is another celestial axis that cuts right through the north and south poles of the Earth. It occurs because of how the very distant radio galaxies and quasars are aligned with the Earth. So now we have three axes that put the Earth in the center of the universe. The discoverer of this third axis, Indian astrophysicist, Dr. Ashok Singhal, concludes with these amazing words. Quote, "It looks as if these axes have a preferential placement in the larger scheme of things, implying an apparent breakdown of the Copernican Principle or its more generalization, Cosmological Principle, upon which all modern cosmological theories are based upon. The Copernican Principle states that Earth does not have any eminent or privileged position, but the Copernican Principle seems to be in jeopardy," unquote. Taken from the article, Is There a Violation of the Copernican Principle in Radio Sky, from the magazine, Astronomy and Astrophysics, May 17, 2013. As Max Tegmark said in the Principle movie. Quote, "The pendulum has begun to swing back the other way from the Copernican Principle," unquote. Another scientist who sees the same is Dragan Hutera from the University of Michigan, who was almost in the Principle. He wrote an article in Astronomy magazine titled, "Why is the Solar System Cosmically Aligned?" He says, quote, "The likelihood of these alignments happening by chance is less than 0.1%. Why cosmic microwave radiation patterns are oriented to the solar system is not at all understood at this time," unquote. Taken from Astronomy magazine, December 2007, pages 38 to 43. Of course, Dr. Hutera doesn't understand it because he fails to see its significance. In reality, it is the most astounding fact modern cosmology has discovered to date. As the scientist Lawrence Vassara once put it, quote, "The alignments of the cosmic radiation should make the hair stand up on the back of your neck," unquote. The unadmitted reason Dr. Hutera doesn't understand it is because it doesn't fit either the Big Bang or the Copernican Principle he takes for granted. But it fits the geocentric universe he is unwilling to accept. Then, there is Dr. Lawrence Krauss, who was also in the Principle. As noted earlier, he was interviewed in 2006 by the magazine titled The Edge, and in it he said these astounding words. Quote, "But when you look at the cosmic microwave map, you also see that the structure that is observed is in fact, in a weird way, correlated with the plane of the Earth around the Sun. Is this Copernicus coming back to haunt us? That's crazy. We're looking out at the whole universe. There's no way there should be a correlation of structure with our motion of the Earth around the Sun, the plane of the Earth around the Sun, the ecliptic. That would say we are truly the center of the universe." Unquote. Ask yourself, if the cosmic radiation alignments that appear to put the Earth in the center were not true, then why would Dr. Krauss say so, since it would be the last thing he would want to admit for his Big Bang Copernican universe? We can say one thing about Lawrence Krauss that we can't say for Mr. Olson, and that is, Krauss is at least willing to admit what the evidence shows even though it doesn't agree with his preferred cosmology. Some Big Bang scientists argue that even though we see this special direction in space, the axis of evil, still, the universe is about 95% isotropic and homogeneous. They then try to argue that since most of the universe is smooth, then the spots are not that important in determining our overall orientation in the universe. Although they are correct about 95% of the universe is homogeneous, to then argue that the axis of evil is of little consequence in how we view our position in the universe would be analogous to saying that even though we see a whole cake of jello, we really don't have to pay too much attention to the two swords that go right through the center of the cake. Modern science must face the facts. The spots are there and they are systematically oriented around our ecliptic and on opposite ends of our equator. If one tries to argue that the dipole and quadrupole microwaves originated from a Big Bang, and the Big Bang developed billions of years later into the universe we presently live in, then how and why did the expanding universe form these strategic spots around our tiny solar system that appear to put the Earth in the center? How would this big universe know or have anything to do with our Earth that, according to the Big Bang, is supposed to be nothing more than a speck of dust out in the remote recesses of space but, as it turns out, is the pivot point for the whole universe? Curious minds want to know. Instead of providing an answer, various critics either give the proverbial runaround, play dumb, or try to minimize the truth, like Dan Olson does. In the face of this clear evidence, if Mr. Olson still insists it is vague, it's because he doesn't want it to be clear, and that is because he's already decided long before he did this video that geocentrism can't be true, and that's partly due to the fact that he is depending on discredited proofs like stellar parallax and Lagrange points to try to prove his position. But now we all know why he is so ignorant, and that is because he doesn't know the science.
Bottom line, geocentrism as a model of the cosmos requires a universe where a series of incredibly consistent physical principles apply to everything else we can see except us. Now, that's exactly what they're trying to imply, but as with Flat Earth, this creates a cascade effect where successively more and more functional, predictive science needs to be discarded in order to make the claim work. You can't just redraw the orbits of the solar system, you need to claim that Earth is gravitationally exceptional. And if Earth is the fulcrum of the universe, then the stellar field needs to be moving at absurd speeds in order to orbit the Earth once every 24 hours, speeds that would be detectable and relativistic. And so you also need to discard relativity, and it all just causes a cascade. And again, that right there is exactly what they're claiming, that they found evidence that should cause us to toss out relativity and universal gravity and everything we've discovered based on those principles, because it disagrees with their model. And since that isn't happening, they claim there's a conspiracy that's suppressing the evidence. And now, on with the show.
No, scientific laws apply all over the universe. We don't have different laws for the stars than we have for us. It all works together since all things work by the same laws of gravity, inertial forces, temperature, pressure, electric charge, mass, and magnetism. But since Mr. Olson insists on making a boogeyman of geocentrism, he states, again without any evidence, that geocentrism believes the laws of nature don't apply to us on Earth that apply to the rest of the universe. By saying such non sequiturs, it is plainly obvious that Mr. Olson doesn't have the slightest idea what he is talking about, but is merely putting words to the biases he already harbors in his mind. He fears a geocentric alternative to the universe because of its theological implications, and since he fears it, he has to dress it up like a monster so that everyone will want to kill it with him. But this is common among amateur scientists like Mr. Olson, as it is common among many physicists in academia. They think they know what they are talking about and thus make all kinds of accusations against a geocentric universe and those who hold it. In reality, hardly any of them know what geocentrism is or teaches. In an earlier part of this video, we went through the differences between Newtonian and Einsteinian physics. We saw that Newton's physics is confined to inertial systems because of Newton's insistence that the universe is absolute. But when Newtonian engineers must change to a non-inertial system, the system that runs most of the universe, they must add in the three inertial forces so that their solar system can function and get their space probes to go to the planets. This shows a major flaw in Newtonian mechanics since the inertial forces are not an inherent part of its physics, as Einstein himself pointed out. In fact, as we showed earlier, Newtonian physics must borrow the three inertial forces from geocentrism in order to allow Newtonian physics to make its model of the solar system. We also showed that Einstein's general relativity, by its very nature, must allow for a geocentric universe, that is, one in which the universe rotates around a fixed Earth. Anyone familiar with the deeper aspects of general relativity must admit this fact, and if they don't, then they either don't know how general relativity works or they are hiding the facts of general relativity. In short, modern geocentrism is following the rules laid out by general relativity, but Mr. Olson seems to have no notion of this fact. So, in order to answer the false claims of Mr. Olson, let's go through them one by one. First, he says, quote, "Geocentrism requires a universe where a series of incredibly consistent physical principles apply to everything else we can see in the universe, except us," unquote. This is false. The principles and equations used in geocentrism apply both to the Earth and the rest of the universe. The problem is that Mr. Olson has never learned what they are. His basic assumption is that geocentrism has excluded gravity, but it hasn't. Gravity applies everywhere. As we saw earlier, what Mr. Olson isn't familiar with is that the Earth is the center of mass for the universe, and by definition, the center of mass doesn't move. We also saw that the Sun and stars can revolve around a fixed Earth because a rotating universe creates the three inertial forces that keep all these celestial bodies in their respective positions. Unfortunately for Mr. Olson, his system, the Newtonian, doesn't have inertial forces because they must regard them as fictitious. Yet when they send space probes to Mars, the Newtonians borrow the inertial forces from geocentrism and treat them as real. As for Mr. Olson's claim that Newtonian gravitational principles must apply everywhere in the universe, yes they should, and that is precisely what's wrong with his system, since there is this pesky little problem in deep space called the galaxy rotation anomaly that defies Newton's physics. It is the fact that, in all galaxies that rotate, they rotate 10 times too fast for Newton's equation, F equals ma, a problem known since the late 1970s. The only way that Copernican scientists have managed to cover over this problem is by claiming that each galaxy contains a mysterious and as yet undetected form of matter that is conveniently dubbed dark matter. In other words, they make up the matter they need to preserve Newtonian physics. Geocentrism has no problem with the galaxies, since the extra acceleration in the galaxies comes from the angular momentum of the universe. That's not all. Mr. Olson's universal gravitational principles have a problem with the fact that most galaxies spin in one direction, but in a gravitationally homogeneous universe, half should spin one way and the other half the opposite. Geocentrism can answer this dichotomy by the fact that the universe spins in one direction and thus the majority of galaxies are going to do the same. Next, Mr. Olson claims, quote, "In geocentrism predictive science needs to be discarded in order to make the claims work," unquote. But as we saw with the galaxies, Newton's F equals ma could hardly predict that the galaxies would rotate 10 times faster. And as we saw earlier, Newton's system cannot predict how to get a space probe to Mars or even how a planet revolves around the Sun unless it borrows the inertial forces from geocentrism. Next, Mr. Olson claims, quote, that geocentrism can't just redraw the orbits of the solar system, unquote. But geocentrism does not redraw orbits. As we have seen, the Tychonic geocentric system is basically a mirror image of the Copernican system. Perhaps Mr. Olson is thinking of the Ptolemaic geocentric system, but whatever he's thinking, he doesn't understand the modern geocentric system. Next, Mr. Olson says, quote, "Geocentrism needs to claim that Earth is gravitationally exceptional," unquote. Not exactly. As noted earlier, geocentrism says Earth is the center of mass for the universe, and because of that fact, then it is in a gravitationally balanced position, as would be expected of the only object in the universe that doesn't move. Gravity still operates in the Sun-planet system, but the gravity is balanced and controlled by the inertial forces, the centrifugal, Coriolis and Euler, that come from a rotating universe. It has recently been discovered that even Newton accepted this possibility. In the last page of his Principia Mathematica that never made it to his publisher, Newton said the following. Quote, "In order for the Earth to be at rest in the center of the system of the Sun, planets and comets, there is required both universal gravity and another force in addition that acts on all bodies equally according to the quantity of matter in each of them, and is equal and opposite to the accelerative gravity with which the Earth tends to the Sun. Since this force is equal and opposite to its gravity toward the Sun, the Earth can truly remain in equilibrium between these two forces and be at rest. And thus, celestial bodies can move around the Earth at rest, as in the Tychonic system," unquote. Taken from Steven Weinberg's book, To Explain the World, The Discovery of Modern Science, published, 2015, pages 251 to 252, and originally taken from George Smith's essay titled, Newtonian Relativity, a Neglected Manuscript, an Understressed Corollary, published, 2013. Unfortunately for Newton, since he insisted on having an absolute universe, he would never discover the origin of the, quote, another force, unquote, since that force, namely, the inertial force, comes from a rotating universe. Next, Mr. Olson says, quote, "If Earth is the fulcrum of the universe, then the stellar field needs to be moving at absurd speeds in order to orbit the Earth every 24 hours, unquote. This is a common complaint against those who are not familiar with the physics, and it again shows Mr. Olson's ignorance of the subject matter. As we noted earlier, general relativity allows the stellar field to move at absurd speeds. But don't take our word for it. Let's consult an expert in general relativity. His name is William Rosser, and he says, quote, "If gravitational fields exist, the velocities of either material bodies or of light can assume any numerical value depending on the strength of the gravitational field. If one considers the rotating roundabout, Earth, as being at rest, the centrifugal gravitational field assumes enormous values at large distances, and it is consistent with the theory of general relativity for the velocities of distant bodies to exceed 300,000 km per second under these conditions," unquote. Taken from Rosser's book, An Introduction to the Theory of Relativity, published, 1964, page 460. In a geocentric universe, the farther the radius from Earth, the stronger the centrifugal gravitational field, and thus the faster light and material objects can travel, thanks to general relativity. Once one accepts general relativity, which is our best science today, one is required to accept the relative universe it teaches. Thus one must give equal possibility to both a universe in which the Earth daily rotates within a fixed star field, and to a universe in which the star field daily revolves at tremendous speeds around a fixed Earth. This is required by the coequivalence and covariance equations that are an inherent part of general relativity, something of which Mr. Olson seems oblivious. Next, Mr. Olson says, quote, "You also need to discard relativity. They have found evidence that should cause us to toss out relativity and universal gravity," unquote. Obviously, if geocentrism uses general relativity to prove the viability of geocentrism, then it doesn't discard relativity. The one throwing out general relativity is Mr. Olson. General relativity, says geocentrism, is a viable scientific position. Mr. Olson says it is not possible. What geocentrism discards is Einstein's previous attempt in 1905 by his special theory to eliminate a fixed Earth from the results of the 1887 Michelson-Morley experiment, in which he claimed the speed of light was constant, and the ether didn't exist. As we noted, Einstein changed his view in general relativity, allowing the speed of light and material objects to exceed c, as well as taking back the ether he had once rejected. As it stands, since there are no inertial zones in the universe except where the Earth is fixed, then the rest of the universe is non-inertial and thus runs by general relativity and thus can exceed the terrestrial speed of light. As for universal gravity, geocentrism has certainly not rejected it, and actually has a better understanding of gravity and how it works with the inertial forces than Copernican science does. Again, Mr. Olson is mistaking flat Earth theories on gravity with modern geocentrism, which accepts universal gravity. In fact, modern geocentrism has an explanation for how gravity works and why it acts instantaneously, whereas Newton only assumed it to be instantaneous but had no explanation why it acted so.
So we actually asked Michio, should we be making a film about the Copernican Principle? And I think his answer is fascinating.
Let's roll the tape and hear what he says.
Could you just tell us who you are and your academic affiliation, anything you'd like the audience to know about you?
My name is Dr. Michio Kaku. That's M-I-C-H-I-O-K-A-K-U. I'm a professor of theoretical physics here at the City University of New York. My latest book, Physics of the Future, is a New York Times bestseller.
A layman should never question the Copernican Principle. They should never question where money's being spent. They should never ask questions of somebody of a higher education on being able to do a documentary at this caliber when talking to people like you. What do you say about that?
Well, personally, I think we should always question everything. First of all, why do we have this crash of 2008? It's because precisely people did not ask simple questions. Simple questions such as, why our property values keep on rising? Won't it ever peak and fall? Nobody asked that question. It's such a simple question, and yet trillions of dollars of value simply vanish because no one asked a simple question. So sometimes the simplest questions are the hardest questions because they go to the root of the problem. And sometimes when we don't answer these simple questions, we get into a lot of trouble.
All right, that does not sound like to me somebody who's saying, don't question.
Yeah. Now, Mike,
Quote, we should always question everything, close quote.
For Kate, it was real simple. She claimed that she was misinformed and that she agreed with Lawrence Krauss that he had been misinformed. I don't quite understand how by quoting Lawrence Krauss, we could be misinforming him. I don't understand how if Kate read this script for 3 weeks, which she did, and her management firm, Due Diligence, did for 3 weeks before that, which they did. This is a New York management firm. What is the possible basis for saying that they were misinformed, that they didn't know? Kate did such a marvelous job on this film. When you watch the film, you're going to see that her incredible narration in this film carries it. She takes us by the hand and leads us through this exploration of these incredibly advanced and powerful concepts, and always seems to ground us. Truth is, her management firm didn't want her going on camera, and we said, okay, that's fine, we don't need her on camera. We just want her for her. She and I got to talking about this, and afterwards she said, is that cameraman still here? Because we were filming the New York footage. I said, yeah. She says, well, I'd like to say a few things. And she went on camera, and she praised the script to the skies.
First of all, the material to me is fascinating. Secondly, I'm not on camera. So there's something very private, relaxed, and deeply creative about it. The first time around, I mean, a lot of this stuff is difficult. I have to organize it in my mind. I have to fully understand it. I have to separate it out. Do you know, it has to make perfect sense to me.
And something clicked for Kate, because when she walked back out here, I walked in and I said, okay, Kate, we've got a great, clean reading. Let's just swing for the fences.
So that the second time around, I can endow it with all the emotion it deserves.
In the book of Genesis, God tells Abraham, "Look up and number the stars, if you can." This is the beginning of faith and the beginning of science.
Now, this next cue, I want you to understand this is what Kate Mulgrew read.
Yes.
Into the microphone. But also pay attention, because now this brings us back to Max. Remember, back in 2011, Max said, I don't think these alignments are, there's probably a mistake there. There couldn't be any connection between our solar system and the cosmic microwave background. Well, this is now post-Planck.
Right.
We went back.
Later data, folks.
2013, 2 years later. I've spent 2 years emailing Max back and forth about this stuff. We've talked about this. And now listen to what, first of all, Kate asks him, or Kate reads from the script, and then listen to what Max says about these weird alignments with our local neighborhood.
All right, let's roll this clip.
But what about the alignments with the ecliptic and equinoxes, which Lawrence Krauss had said would mean we were really the center of the universe? We asked Max Tegmark if Planck's results had convinced him that the axis of evil actually was aligned with our ecliptic and equinoxes.
I have to confess that I was bothered by the fact that the axis of evil seemed linked to a special direction in our solar system, and something in my gut was telling me that this might, even though I greatly trust the people on the WMAP team, point to something fishy in their analysis. But I also feel very strongly that I have to actually override my gut by using my brain and by looking at data. And now we have completely independent data with better detectors, completely different people seeing the same thing. So there's just no way we can blame this on the WMAP team.
Well, after the Vora show aired, everything began to change. What we noticed is that more and more people in the comm boxes started noticing that, you know, it really doesn't make sense. Kate Mulgrew would sit there and read the script for a month. Her New York management firm would do a due diligence on the company, its principals, everybody who was involved with. They were all listed on our IMDb page. Nobody was hiding anything. I checked the film thousands and thousands and thousands of times, and there's just nothing about the Jews in the film. It just isn't. It's a film about cosmology. It's a film about the Copernican Principle. But the tide had turned. People were beginning to recognize that this story, this Captain Janeway and the Seven Cosmologists fairy tale, just didn't hold up to even the most basic logical scrutiny. And consequently, we were able to bring the project to completion and to secure that wonderful opportunity that so few independent films get, to actually be able to show the film in theaters. And that is precisely what we ended up doing in October of 2014 when we opened the film in Chicago. I'm hoping that sanity can be restored here. Everybody got scared. Everybody decided, oh, I've been doing, you know, let's be adults here. We've made a film. Let's let the film stand on its merits. Let's stop reviewing the film if we haven't seen the film. And let's stop being so terrified of the possibility that the Earth might be in a special place in the cosmos. At the end of the day, 400 years ago, Giordano Bruno was burned on the streets of Rome for daring to question the place of Earth in the cosmos. Now, thank God I haven't been burned at the stake, but is it possible that we still have questions that we're not allowed to ask? Have we come full circle to the point where we're not even allowed to ask the question anymore? Could Earth be the center of the universe? What would it mean for our view of ourselves, our culture, our destiny? What would it mean if it were to turn out that we really are special? If we've reached a point where that question cannot even be asked anymore, then we have a bigger problem than I ever would have imagined. It is my sincere hope that no matter what your personal views on this may be, that you will insist on the right of filmmakers and other artists and investigators to ask even the most controversial, even the most uncomfortable questions, and to make sure that that right is always upheld and protected, especially when the questions really get to the very foundation of what it means to be human.